This episode of Mathematics with Mr. Richardson is brought to you by Pythagoras, proudly taking credit for the work of his homies since 571 BC. Section 8.3, Rotations. What you'll learn: to graph rotations and to identify rotational symmetry. New vocabulary: rotation, center of rotation, angle of rotation, and rotational symmetry. Why learn this? When you learn to recognize rotational symmetry, you can see it in everything from art and nature to architecture and science. And now for a quick check of the skills you'll need for this section. Number 1, vocabulary review. When a figure has reflectional symmetry, one half blank, the other half exactly. And numbers 2 through 7, classify each angle as acute, right, obtuse, or straight. And some vocabulary. A rotation is a transformation that turns a figure about a fixed point called the center of rotation. A figure has rotational symmetry if it can be rotated 180 degrees or less and exactly matches its original figure. When you rotate a figure about a point, the image is congruent to the original figure. A rotation changes only the position of the figure. The angle of rotation is the number of degrees the figure rotates. A complete rotation is 360 degrees. Take note the images below. We have a center of rotation on this, that's something of a bike seat shape. We can often think of that as almost like a pin, like a thumbtack, pinned through the figure, and it's going to rotate around that center, that point. So notice first, a rotation to the left of 90 degrees is considered a 90-degree rotation. Keep in mind that's counterclockwise. Sometimes, to some students, and to me as well, it almost seems intuitive that we should move clockwise to count a 90-degree rotation. I'm not sure why it is that some students and I feel that way, but we're going to consider a counterclockwise rotation to be a rotation in positive degrees. So notice also a rotation of 180 degrees. Our bike seat, if that's what we'll call it, is pointed in the opposite direction from where it originally was. 270 degrees, well, that's 1, 2, 3/4 of the way around a complete circle. And finally, a full circle, 360 degrees. Example problem number 1, rotational symmetry. Nature. Find the angle of rotation of the figure. The image matches the original after 1/5 of a complete rotation. We can determine that by considering how many points this starfish has. 1, 2, 3, 4, 5 points, and assuming that it's symmetric and that each of those points is evenly distributed around the full 360 degrees of the starfish, then at each 1/5 of 360 degrees, the starfish's point would overlie perfectly the next point. And maybe to better understand that, imagine, it seems sad, but imagine that starfish was pinned in its center, and then it was able to rotate right around that center. Just note that after 1/5 of a full rotation, the points would overlap, or every point would overlap the next point to its left, or counterclockwise. So we need to determine what 1/5 of a full circle, or of a full 360 degrees, equals. That's easy enough. We multiply the fraction 1/5 times 360, or divide 360 by 5, and find 72 degrees. So the angle of rotation for this figure is 72 degrees. And a quick check problem. Number 1, if the figure at the right has rotational symmetry, find the angle of rotation. If it does not, write no rotational symmetry. And example number 2. Graph triangle ABC and its image after a rotation of 90 degrees about the origin. Name the coordinates of the vertices of triangle A', B', C'. So bear in mind, our center of rotation in this problem will be the origin. Now, you should note that's not always going to be the case, but in this problem, it is. Now, as I mentioned before in a previous video, I like to imagine that each vertex is connected to the center of origin with like an invisible string. I probably think of like monofilament fishing line. Something like that, but you have to imagine those strings are all nice and tight. So the idea is that each vertex is connected to the center of origin, and now, keeping those strings tight, we're just going to rotate the figure. In this case, 90 degrees counterclockwise. And so we have to imagine where would each of these vertices end up if we did that. Let's first consider the point A. Note the point A is, well, from the center here, the center of rotation, which we also call the origin. It is to the right 1, 2, 3 units, and up 1, 2, 3 units as well. So imagine this L shape that I've just drawn, but rotated 90 degrees. You know, think about it, that L shape would end up here and look something like that. Look at that, it's even crooked where I made the last one crooked. Not deliberate. That means that our point A' will be located here at the point -3, 3, after a 90 degree rotation. Let me clean this up just a bit. And we'll consider points B and C as well. So the point B, well, that is right 1, down 1. So now imagine this little L shape rotated 90 degrees. Well, if it begins by going to the right 1 unit, we rotate 90 degrees, 1/4 of a full circle. Now it will begin by going up 1 unit and to the right 1. So there's our point B'. And finally C'. Now C itself, the pre-image vertex, is to the right 1, 2, 3 units and down 2. So right 3, down 2. So instead of going right 3 and down 2, I'm going to go up 3, 1, 2, 3, and to the right 2. So again, imagine it's just that L shape, but rotated 90 degrees. And that gives us our post-image vertex of C'. Then we connect in a more professional way. Connecting A', B', and C', we find our post-image triangle, A', B', C'. Keep in mind, you don't necessarily have to construct all those L shapes like I did. That's really helpful. It's very useful, especially when you're first starting out graphing rotations. But that's something you can do mentally. You can just imagine the L shape and imagine rotating it. Of course, you may get so good at this that you can imagine the lines, those gray lines that I drew. Imagine those holding the figure in place and then rotating 90 degrees. Perhaps you can visualize right where the vertices would end up. In any case, we were asked to name the coordinates of the vertices of A', B', C'. I see the answer is already at the bottom, so I'll just verify that my answer matches. A' is -3, 3. 1, 2, 3, and up 3. Excellent. B, 1, 1. Got it. And C, oh, I'm sorry, I called that B. B', 1, 1. C', 2, 3. Right 2, up 3. Got it. And a quick check. 2. Graph triangle ABD and its image after a rotation of the given number of degrees about the origin. Name the coordinates of the vertices of the image. And your check your understanding problems for this section. There are 4 of them.